Hey everyone, welcome back to the deep dive.
Yeah.
You know the drill, right? We take those dense, information-packed topics you're eager to understand, but don't always have the time to fully explore, and we dive deep. Today we're tackling the world of resources and development, and you've given us some great textbook excerpts to guide us. We'll be focusing specifically on land and soil in the context of India, so get ready for a fascinating journey. No textbook required.
Yeah, these excerpts are a fantastic starting point. They cover so much ground, from the very basics of what a resource is to the crucial importance of conservation efforts. We'll break it all down step by step, making sure you grasp the core concepts without getting lost in the details.
Let's get right into it then. First things first. What exactly is a resource? The textbook lays out a pretty straightforward definition. It's anything, any source or supply that can provide us with some sort of benefit.
Right, and that doesn't just mean physical stuff, like materials or energy sources. It can also include things like services or even knowledge, those less tangible but equally vital assets. Absolutely.
Right.
And it's easy to forget about those most fundamental resources we depend on every single day. The book highlights these right away: air, water, sunlight, land, the very foundation of life itself.
And what's really interesting is how the human element comes into play. The textbook emphasizes that it's not enough for something to simply exist in our environment to be considered a resource. For us to actually harness it, it has to meet certain criteria.
It has to be more than just potentially useful, right? We need to be able to actually use it.
Exactly. It needs to be technologically accessible, meaning we have the tools and know how to extract and utilize it. It has to be economically feasible, so the benefits outweigh the costs of obtaining it. And, crucially, it must be culturally acceptable, fitting within the values and practices of our societies.
That's a really interesting point about cultural acceptance, how what's considered a valuable resource can actually vary depending on the cultural lens you're looking through.
Absolutely. Think about how different cultures might perceive a particular plant, for example. One might see it as a nuisance weed, while another might recognize it as a source of food or medicine. And even the concept of a natural resource itself has evolved over time, hasn't it?
Yeah, for sure. Initially, the focus was primarily on those raw materials, minerals pulled from the earth, fossil fuels we extract for energy. But as our scientific understanding and technological capabilities have expanded, our view of what constitutes a natural resource has broadened significantly.
Definitely. As the text points out, we now recognize the value of all living and non-living components of our environment as potential resources. Think about something like biodiversity, for instance. The sheer variety of life on Earth, we now understand its crucial importance for ecological balance, for its potential in fields like medicine, and even for its role in industries like tourism. It's not just about seeing a forest as a source of timber anymore. It's about recognizing the complex web of benefits it provides.
And this leads us to some really important concepts. The textbook links directly to resource use ideas like competition for limited resources, the absolute need for sustainable practices, the active efforts of conservation, and this notion of stewardship, our responsibility to care for the resources we have. It highlights that resource management isn't just about finding and extracting, it's about planning, careful allocation, and making sure those resources are available for the long haul.
It's about thinking generations ahead, not just for immediate gains. And building on that, the text really positions us, humanity, as the driving force behind resource creation. It's our ingenuity, our knowledge, and our labor that transform a raw element from the natural world into something truly useful to us.
Right, we play a huge role in adding value and utility to what we find in nature. And speaking of how we define and categorize those things we find, the textbook lays out a really helpful distinction: natural resources versus man-made resources.
A fundamental differentiation. Natural resources exist independently of human action. They're the things we find in nature in their raw form. Think land, water, air, minerals. Man-made resources, on the other hand, are what we create by modifying those natural elements to suit our needs.
So that would be things like buildings, roads, machines, all the stuff we build and use.
Exactly. And it goes even further, actually. The text also introduces the concept of humans as a resource. This refers to the skills, knowledge, and capabilities that individuals bring to the table: a teacher's expertise, a doctor's training, an engineer's problem-solving skills. All of this is seen as a form of human capital that contributes to societal development.
Makes total sense. Human ingenuity and skill are definitely resources in their own right, driving progress and innovation. Now, the book moves into classifying these diverse resources, and it does so in several different ways.
It gives us a few different lenses to look through. First, it divides them based on their origin: biotic and abiotic. Biotic resources, as the name suggests, come from the living world, plants, animals, and, yep, us humans too.
And these are generally considered renewable, right? Meaning they have the capacity to regenerate over time.
That's right. But it's important to note that the speed and reliability of that renewal can vary widely. Some biotic resources regenerate quickly, like a field of wheat, while others, like a mature forest, take much longer. And some require very specific conditions to regenerate effectively.
Makes sense. So what about abiotic resources?
Those originate from the non-living components of our planet land: water, air, minerals. And it's interesting to consider, while natural resources can be either biotic or abiotic in their origin, anything that falls under the category of man-made resources is inherently abiotic because it's created by modifying those non-living elements.
That's a good point. Now, another key way the text classifies resources is based on their exhaustibility. This is where we get into the crucial distinction between renewable and non-renewable resources, which has huge implications for how we manage them.
Right, this is a big one. Renewable resources are those that can replenish themselves over time through various natural processes. They might be physical, chemical, or biological processes, but the key is that they have the potential to regenerate.
So things like forests that regrow, wildlife populations that reproduce, solar energy that constantly arrives from the sun, those are all renewable resources.
Precisely. And we can break down those renewable resources even further. The text talks about continuous resources like solar radiation, wind, and tides. These are essentially available to us all the time, and we don't noticeably diminish them by using them.
It's almost like an endless supply, at least on human timescales. What's the other type of renewable resource?
Those are the biological resources, which are essential for the growth and reproduction of living organisms, think plants, animals, and the ecosystems they form. They can replenish themselves, but it's important to remember that they can still be overexploited if we use them faster than they can regenerate.
Like if we cut down trees faster than new means can grow, or fish at a rate that depletes the population.
Exactly. Now, on the flip side, we have the non-renewable resources. These are the ones that form over extremely long periods. We're talking millions of years, often through geological processes. This means that, for all practical purposes, they are finite. We can use them up.
And those are primarily the minerals, metals, and fossil fuels, coal, petroleum, natural gas, that power so much of our modern world.
Right. And even within this category of non-renewables, there's a further distinction. Some are considered recyclable, meaning that we can recover and reuse the materials. Metals are a good example. We can melt down and reprocess them multiple times. But then there are those that are essentially non-recyclable. Think coal and petroleum. Once we burn them, they're gone and we can't easily recover them.
So in those cases, it becomes even more crucial to use them wisely and to explore alternative, renewable sources. Now, the text also dives into how we categorize resources based on ownership, and this is where we get into some interesting distinctions as well.
Ownership is a key factor in how resources are managed and utilized. The first category the text outlines is individual resources. These are owned by private individuals. Think of your home, your car, or a piece of land you own.
Makes sense. So what's next?
We have community resources. These are owned collectively by a community and are often accessible to all members of that group. This could be a public park, a community forest, grazing lands used by a village, or shared water sources.
These are the resources that are meant to benefit everyone in a particular area.
Exactly. Then we step up to the national level with national resources. These belong to the country as a whole and are managed by the government on behalf of its citizens. Think forests, mineral deposits, rivers, and the territorial waters that extend out from a nation's coastline. These are often crucial for a country's economic development and security.
I imagine control over those resources can sometimes be a source of tension between nations, especially when they cross borders.
Absolutely. And finally, at the broadest level, we have international resources. These are those that are governed by international institutions and agreements. They don't belong to any one nation. The open ocean beyond national jurisdictions is a prime example, as is outer space. Managing these resources often requires cooperation and coordination between multiple countries.
Makes sense. We need international frameworks to prevent conflict and ensure responsible use. Now, the last way the text classifies resources is based on their status of development, and this one has a few more layers to unpack.
Yeah, this one gets a bit more nuanced. It starts with potential resources. These are resources that we know exist in a certain region but haven't been fully explored or quantified. It might be the potential for solar power in a sunny desert area, or the possibility of mineral deposits in a particular geological formation. The key is that we haven't yet determined their exact quantity and quality.
So it's like we know there's potential there, but more investigation is needed to understand the full extent of it.
Precisely. Then we have developed resources. These are the resources that have been thoroughly surveyed, and their quality and quantity are well understood. Crucially, they're currently being utilized.
So coal mines that are actively producing coal, oil wells that are pumping oil, those are examples of developed resources.
Exactly. Then we have stock resources, which is an interesting category. These are materials in the environment that could potentially satisfy human needs, but we currently lack the technology to use them effectively.
Like, we know they're there, but we haven't figured out how to harness them yet.
That's the idea. The textbook gives the example of hydrogen and oxygen in water. We know that splitting water molecules could provide us with abundant clean energy, but we haven't yet mastered the technology to do so on a large scale in a way that's economically feasible.
So those hydrogen and oxygen atoms are just waiting there, like a vast storehouse of potential energy we haven't unlocked. What's the final category in this classification?
That's reserve resources. And this one's closely linked to the stock category. Reserve resources are a subset of stock resources. They are those that we do have the technical know-how to utilize, but we haven't started using them yet.
So we've got the technology and the knowledge, but they're not being actively exploited at this point.
Exactly. Think of a forest that's been identified as having high-quality timber but hasn't been logged yet, or a mineral deposit that we know is there but hasn't been mined. These are resources being held in reserve, either because we're choosing to conserve them or because it's not economically viable to exploit them at the current time.
It's like a strategic decision. We know they're there if we need them, but we're not tapping into them just yet. Now, once the textbook has established these various classifications, it shifts gears to the crucial issue of resource development and the challenges that come along with it.
Which makes sense. Once we understand what resources are and how we categorize them, the next logical step is to think about how we utilize them for our benefit.
And it's obvious why resources are so important. They're the basis of our survival, our economies, our standard of living, everything. But as the text points out, there are some serious problems that arise when we don't use these resources carefully and sustainably.
Right, there are consequences to our actions. The text highlights a few key issues. Depletion of resources, particularly those that are non-renewable, which can lead to scarcity and conflict. Then there's the issue of unequal distribution, which often exacerbates the gap between wealthy and impoverished nations and communities. And of course, there's the environmental impact, pollution, habitat destruction, climate change. These are all tied to how we extract, process, and consume resources.
It paints a pretty stark picture of the potential downsides. So what's the solution? How do we address these challenges?
The textbook points to the concept of sustainable development as the way forward. This is the idea of meeting our present needs without jeopardizing the ability of future generations to meet their own needs. It's about finding a balance between economic progress, environmental protection, and social equity.
It's not just about using less, right? It's about fundamentally changing how we think about resources and development.
Exactly. It's about shifting from a linear take-make-dispose model to a more circular and regenerative approach, where we minimize waste, reuse materials, and strive to create systems that are in harmony with the natural world.
It's a big picture way of thinking about our relationship with the planet. And speaking of big picture perspectives, the textbook highlights the importance of international cooperation on these issues. It specifically mentions the 1992 Rio Earth Summit, also known as the UN Conference on Environment and Development, as a landmark event.
Right, the Rio Summit. This was a pivotal moment for bringing global attention to the interconnectedness of environmental protection and socioeconomic development. It wasn't just about acknowledging the problems, it was about taking concrete steps to address them collectively. What's important to understand is the context. The Rio Summit followed the earlier Stockholm Conference in 1972, so it represented a significant step forward in global recognition of the importance of environmental issues.
And it resulted in some key agreements, right? The textbook mentions the Global Forest Principles and the development of Agenda 21.
Absolutely. The Global Forest Principles were aimed at promoting sustainable forest management practices, recognizing the vital role forests play in maintaining ecological balance, absorbing carbon dioxide, and supporting biodiversity. Agenda 21 is really the heart of what came out of the Rio Summit. It's a comprehensive blueprint for achieving sustainable development in the 21st century. And a key aspect of Agenda 21 is its focus on empowering local governments and communities to implement those sustainability practices. It emphasizes the need for global cooperation to tackle issues like environmental degradation, poverty, and disease. It's a powerful call to action at all levels, local, national, and international.
So it's not just about top-down solutions, it's about empowering communities to make a difference. Now, shifting our focus a bit, the textbook delves into resource planning specifically within India. It notes that while India is rich in natural resources overall, there's significant unevenness in their distribution across different regions.
Yeah, India is incredibly diverse in its geography and its resource endowments. It's a country of contrasts. You have states like Odisha, Jharkhand, and Chhattisgarh that are relatively rich in certain minerals and forest resources, while others, like Punjab and Haryana, are more agriculturally focused, and states like Arunachal Pradesh might have different resource strengths and weaknesses.
And this uneven distribution makes effective resource planning even more critical, right?
Absolutely. The text emphasizes the need for well-coordinated resource planning at both national and regional levels to ensure that development is equitable and benefits all parts of the country. It can't just be about maximizing resource extraction in one area while neglecting the needs of others.
So how does this resource planning process actually work in India?
The textbook outlines several key stages. First, it starts with a thorough identification and inventory of all available resources across different regions. This involves detailed surveying, mapping, and quantitative assessments.
So really understanding what's there, where it's located, and how much of it there is.
Precisely. Then, the next step is planning for resource development, which goes beyond simply identifying the resources to strategizing how they can be extracted, processed, and utilized most effectively. This involves considerations like skill development, appropriate technologies, and establishing the institutions and infrastructure necessary to support those activities.
It's about making sure the benefits of those resources are actually realized.
Exactly. And then finally, these localized and regional resource development plans need to be aligned with national development goals to create a cohesive strategy.
It sounds like a complex balancing act, making sure that regional needs and national priorities are working in tandem.
Absolutely. It requires careful coordination.
Yeah.
And it's interesting to note that India actually began this process of systematic resource planning fairly soon after gaining independence, with the launch of its first five-year plan in the early 1950s.
I didn't realize it went back that far.
Yeah, it's been a part of India's development strategy from the beginning, and the textbook points out that this concept of five-year plans with centralized planning and targets was inspired by the model being used in the Soviet Union at that time.
A very top-down approach. But it makes sense in the context of a newly independent nation trying to rapidly develop its economy and infrastructure.
Right. And speaking of historical context, there's a really crucial lesson connected to resources that the textbook emphasizes: the legacy of colonization. It talks about how the European powers were drawn to India precisely because of its abundant natural resources, and how they were able to exploit those resources effectively because they had more advanced technologies at their disposal.
That's a really important point. It wasn't just about the resources themselves, it was also about the technological capacity to extract and utilize them.
Exactly. And this historical experience was a stark lesson for India, that simply having resources isn't enough. It also requires technological capabilities, a skilled workforce, and the institutions and systems needed to manage those resources effectively.
It's a reminder that development isn't just about what you have, it's also about how you use it.
Absolutely. And this leads us to the vital concept of resource conservation, which the textbook defines as the wise and planned use of resources to meet present needs while ensuring their availability for future generations. It's about recognizing that these resources are finite, even the renewable ones, and that we have a responsibility to manage them carefully.
It's about being good stewards of what we have. And there's a fantastic quote from Mahatma Gandhi that the textbook includes here. "There is enough for everybody's need, but not enough for anybody's greed." It really cuts to the heart of the issue that overconsumption and unsustainable practices are driven by greed rather than genuine need.
Such a powerful statement, and it's relevant now more than ever as we grapple with the consequences of overexploitation. The textbook goes on to highlight some major global initiatives that have championed resource conservation. It starts with the Club of Rome back in 1968, which was one of the first organizations to systematically raise concerns about the limits to growth and the need for sustainable resource management. Then there's E.F. Schumacher's influential book, Small is Beautiful, published in 1974, which advocated for a more human-scale, environmentally conscious approach to development, drawing significantly from Gandhian philosophy.
It's interesting how those ideas from the 70s are even more relevant today as we become increasingly aware of the environmental costs of our growth-obsessed economic model.
Absolutely. And the text also mentions the 1987 Brundtland Commission report, officially titled Our Common Future, which is credited with popularizing the now widely used definition of sustainable development, meeting the needs of the present without compromising the ability of future generations to meet their own needs. And of course, the 1992 Earth Summit in Rio de Janeiro is highlighted again as a pivotal moment for establishing international frameworks and commitments for environmental protection and resource conservation.
It's clear that building international consensus and cooperation is key to tackling these global challenges. Now, the text then zooms in on a specific resource land, looking at it in the context of India. It underscores the fundamental importance of land, pointing out that it supports virtually all human economic and cultural activities from agriculture and industry to transportation and simply providing the space we live in.
It's something we often take for granted, but land is essential for everything we do. And it's quite remarkable when you think about it. India, despite having one of the largest and most diverse populations in the world, actually accounts for only about 2.4% of the Earth's total land area.
That's a pretty small percentage considering how many people live there.
Right. And even within that limited land area, there's an incredible diversity of landforms. The textbook notes that about 43% of India's land consists of plains, which are crucial for agriculture and urban development. About 27% is made up of plateau regions, which are often rich in mineral resources and forests, and then about 30% comprises mountains, which play a vital role in the water cycle, providing a source for perennial rivers. Mountains also offer opportunities for tourism and are home to unique ecosystems.
So that diversity in landforms shapes not only the landscape, but also the economic activities and livelihoods of different regions.
Exactly. And the text goes on to discuss land utilization patterns in India, how land is categorized and used for various purposes.
Yeah.
And this is shaped by a combination of factors, both natural and human influenced.
Right. Things like climate, soil type, topography, those are the natural constraints. And then you have human factors like population density, cultural practices, technological advancements. All of these influence how land is used.
Exactly. And the main categories the text outlines are forests, land not available for cultivation. That includes things like barren land, wasteland, and land used for buildings and infrastructure. Then there's other uncultivated land, which includes permanent pastures, land under miscellaneous tree crops, and cultivable wasteland. Then you have fallow land, which is land that's been left uncultivated for a period of time. And of course, the most crucial categories for agriculture are net sown area and gross cropped area. Those are the lands actively being used for crop production.
It's fascinating to think about how these different land uses often compete with each other, and the choices we make have significant consequences for the environment, the economy, and even social dynamics.
Absolutely. And there are some interesting insights that the text highlights when looking at land utilization patterns in India. One is that while forest cover has been slowly increasing, it's still below the nationally desired target of 33% of total land area. It's currently somewhere in the mid-20% range. So there's a continued push to expand forest cover, recognizing the vital role forests play in ecological health.
So there's still work to be done on that front. What else stands out?
Another interesting point is the contrast in net sown area across different states. In the agriculturally intensive states of Punjab and Haryana, over 80% of the land is dedicated to cultivation. Whereas in more mountainous and forested states like Arunachal Pradesh, that percentage drops significantly, often to less than 10%. That really highlights how geography influences land use and agricultural practices.
Right, the landscape itself dictates what's possible, but with so much land under cultivation and other forms of intensive use, the problem of land degradation becomes a major concern.
Absolutely. The text talks about how human activities like deforestation, overgrazing, unsustainable mining practices, over-irrigation leading to waterlogging and salinity, and pollution from industrial waste, all of these contribute to the decline in land quality and productivity.
And those are all human-induced factors, which means we have the power to change them, right?
Yep.
But the text also mentions natural forces that play a role.
Right. Running water can cause soil erosion, leading to the formation of gullies and ravines like those found in the Chambal region. And wind can be a major factor in arid and semi-arid regions, causing soil loss through a process called deflation. So the combination of human pressures and natural processes that we need to address.
And to do that, the textbook outlines a number of important conservation measures.
Yeah, these are crucial for protecting our land resources. They include afforestation, proper management of grazing lands, regulations to control mining activities, responsible disposal of industrial waste, managing water bodies to prevent pollution, and adopting water-efficient irrigation techniques.
It's a multifaceted approach, addressing the problem from multiple angles. Now, shifting gears a bit, let's delve into another vital resource the text covers in detail: soil.
Soil is often overlooked, but it's truly the foundation of terrestrial life. The text emphasizes that it's a crucial renewable natural resource, although it's important to remember that the process of soil formation is extremely slow. It can take thousands or even millions of years to develop a fertile layer of topsoil.
That's amazing to think about. This thin layer we depend on for so much takes millennia to form.
It's a delicate balance. And soil is more than just dirt. It's a complex ecosystem, teeming with life. It's composed of minerals weathered from the parent rock, organic matter from decomposed plants and animals, water, and air. And the specific composition of a soil depends on a number of factors, including the parent rock material, the climate, the topography, the types of vegetation present, and of course time, that crucial element that allows all these processes to interact and develop.
It's like a slow cooking recipe, with all those ingredients simmering for centuries to create something amazing. And the textbook gives us a glimpse into this complexity when it talks about the soil profile.
Right. The soil profile refers to those distinct horizontal layers, or horizons, that you see when you dig down into the soil. Each horizon has its own unique characteristics based on the processes that have shaped it.
So it's like a history book of the soil, with each layer telling a story. But what really gets interesting is when the textbook delves into the major soil types found in India.
India has an incredible variety of soils, reflecting its diverse geography and climate. Let's start with the most widespread type: alluvial soil. This is the soil that covers much of the northern plains and river valleys. It's formed by the deposition of sediments carried by rivers like the Indus, Ganga, and Brahmaputra, and it's known for its fertility.
So that's why those regions are so agriculturally productive, that rich soil.
Precisely. Alluvial soil is rich in nutrients like potash, lime, and phosphoric acid, which makes it ideal for growing a wide range of crops, including rice, wheat, and sugarcane. The text also distinguishes between two types of alluvial soil: Kadar, which is the newer, finer, more fertile soil deposited in the floodplains near the rivers, and Bangar, which is the older, coarser alluvial soil found further away from the active river channels.
So the age of the soil also plays a role in its fertility. Okay, what's another major soil type?
Black soil, also known as Regur soil or black cotton soil, is found extensively in the Deccan Plateau region, particularly in states like Maharashtra, Madhya Pradesh, and parts of Gujarat and Andhra Pradesh. It's formed from the weathering of volcanic rocks and has a remarkable capacity to retain moisture.
I've heard that black soil is really good for growing cotton. Is that true?
Absolutely. And that's where it gets its name, black cotton soil. It's also rich in minerals like calcium carbonate, magnesium, potash, and lime, but tends to be low in phosphorus. It has some unique characteristics. It becomes very sticky when wet and develops wide cracks when it dries out.
It sounds like a challenging soil to work with.
It can be, but its moisture-retaining properties make it highly suitable for certain crops. Okay, let's move on to red and yellow soils. These are found in various parts of India, often in regions with warmer climates and moderate rainfall. They develop from the weathering of crystalline rocks like granite and gneiss.
And they get their color from iron oxide, right?
Exactly. The reddish color comes from iron oxide, and it often takes on a yellowish hue when it's hydrated. These soils are generally less fertile than alluvial or black soils, but they can support a variety of crops with the help of irrigation and fertilizers.
So they can still be productive with proper management? What about laterite soil? I've heard of that, but I'm not sure what makes it unique.
Laterite soil forms in regions with high temperatures and heavy rainfall, leading to intense leaching of nutrients. This leaching process removes silica and lime, leaving behind concentrations of iron oxide and aluminum compounds.
So it's almost like the nutrients are being washed away?
In a way, yes. This makes laterite soil generally less fertile and with lower humus content, but it can still support certain crops, particularly plantation crops like tea, coffee, rubber, and cashew nuts.
Interesting. So different soils for different crops. Now, what about those drier regions? What kind of soil is found there?
In the arid and semi-arid regions of India, you find arid soil, also known as desert soil. It's characteristic of places like Rajasthan and parts of Gujarat and Haryana that receive very little rainfall. This soil is typically sandy in texture, often saline, and has low levels of humus and moisture due to the dry conditions.
So not ideal for agriculture then?
It can be challenging, but not impossible. With the help of irrigation, even arid soil can be made productive, and crops like barley, wheat, cotton, millets, and pulses can be grown.
So even in challenging environments, human ingenuity can find ways to work with nature. Now, what about the hilly and mountainous areas? What type of soil is found there?
That's forest soil, or mountain soil, and as you might expect, it's found in those regions that receive adequate rainfall. Its characteristics can vary depending on the specific location, altitude, and vegetation cover. But generally, it tends to be more coarse-grained on the upper slopes and more loamy and fertile in the valleys. In areas with prolonged snow cover, the soil can be acidic and have low humus content. But overall, forest soils support a variety of vegetation, including forests and plantations, and in suitable areas could be used for crops like rice and wheat.
So once again, a diversity of soil types reflects the diverse geography of India. But just like with land, soil is also vulnerable to degradation, right?
Unfortunately, yes, soil erosion is a major problem, and it's essentially the removal of that valuable topsoil by agents like water, wind, and glaciers. The text uses the term denudation to describe the overall wearing away of the Earth's surface.
And it's a natural process, but human activities can significantly accelerate it, right?
That's the key point. Things like deforestation, overgrazing, unsustainable construction and mining, and poor agricultural practices can all expose the soil and make it more vulnerable to erosion, and then the natural forces running water and wind come into play and carry that topsoil away.
It's a double whammy. We make the soil more susceptible, and then nature takes over and does the damage. So what can be done to address this?
The textbook outlines several important soil conservation methods. Many of them align with the strategies for land conservation, like afforestation, controlling grazing, and building dams to regulate water flow. But there are also some specific techniques that are particularly effective for soil conservation.
Like contour plowing. I've heard that's good for preventing erosion on slopes.
Exactly. Contour plowing involves plowing along the contours of the land rather than up and down the slopes, which helps to slow down water runoff and prevent soil loss. Terrace farming is another technique used in hilly areas. It involves creating a series of flat steps or terraces on the slopes to reduce the speed of water flow and soil erosion. And strip cropping, planting alternating strips of different crops, can also help to reduce erosion.
And then there are things like creating shelter belts of trees to reduce wind erosion and building rock dams to slow down water flow.
All of these methods work by either reducing the erosive power of water and wind, or by enhancing the soil's resistance to erosion through improving its structure and cover.
So it's a combination of preventative and restorative approaches. Now, towards the end of the textbook excerpts, there's a section dedicated to answering some key questions about the topics we've covered. I think this is a really useful way to reinforce some of the key concepts.
Absolutely. It's a good way to test our understanding. So let's go through a few of the highlights. For instance, one question asks about the major states where black soil is found and the crops that are typically grown there: cotton, wheat, groundnut. Another asks about the characteristics of the soil found in the river deltas of the eastern coast. We know that's alluvial soil, right? Very fertile, ideal for crops like sugarcane, rice, and wheat. And those are also densely populated areas because of the agricultural productivity.
It's all connected, isn't it? The geography, the soil, the crops, the population density.
Exactly. And another question focuses on measures to control soil erosion in hilly areas, contour plowing, terrace farming, strip cropping, creating shelter belts, afforestation, and controlling grazing. All those techniques we talked about earlier.
And we also get a reminder about the difference between biotic and abiotic resources with clear examples. Biotic resources, those that come from living organisms, plants, animals, humans, and abiotic. Those from the non-living world, land, water, air, minerals.
Right, back to the basics. And the question that really gets you thinking is the one about why the increase in forest cover in India since the 1960s hasn't been as substantial as desired. It's a complex issue, but the text points to a few key factors: pressures from agriculture, the need for more